equation to two limits. Are these two really like huge stretches of the imagination?
Yes.
No. Because remember, whenever you're approaching, you're just trying to look to the heights, right? So look to the heights. What is the height? It's just k. So the limit is that constant. And we'll see some examples. B, I wouldn't even stress about too much because it'll be super, just be intuitive as we go along. Now, this one I know. You're like, oh, there are so many properties. However, don't stress. Here we go. I'm going to kind of narrow this down. First of all, suppose that you're given two limits, but you don't know f and you don't know g. You have no clue what the functions are, but they just tell you. The limit as x approaches, give me a random constant.
2.
Okay.
1 million.
The limit as x approaches 2 of f of x is a constant, is a number, is an answer for the limit. And the limit as x approaches that same 2 of g of x is another number. Here's what this entire theorem is telling us. It's basically telling us, how do you work with limits? Well, if you have the sum of two different functions, you're going to be able to split up and take the limit of each, and if you know what the answers are, well, it's just going to be the limit of f plus the limit of g, as long as they're approaching the same constant. The things I'm boxing, the things I'm circling are the most important. The limit of the difference, well, that's not going to be too bad. Just subtract the limits. Limit of a product. You are allowed to split apart limits. Why is that helpful? Well, if I was to take the limit of something like, I don't know, x over x squared plus 1. If I was to take the limit of something like x over x squared plus 1, is that a basic graph? No, it's not a basic graph. So how would I do it? Well, I could try to split up the limit with some of these cool properties. So the product can be split up, a difference, not a difference, a quotient can be split up as long as it exists. If the denominator is 0, it's not quite as fun. And I can also take apart compositions. I can take a radical out of the limit. So once again, you don't have to have this whole thing memorized word for word. You don't even necessarily need to write all the words in between. I'm just trying to say, suppose that this is true, you're allowed to break down limits and do the math without having to think of what is that sum, what is that difference, what is that product, what's the shape of the graph look like of this quotient. You can think of them individually. Yeah. That answer? Oh my goodness. Little people. They're so cute. Yeah. When do you guys have siblings in middle school? Oh. Are they the loud ones or the quiet ones?
Oh, he's quiet.
Oh, he's like,
Depends on the day.
no, not quite. Just because the addition is addition of the limits. So it's not so much there's a new operation involved. It's more like you don't have to go crazy. I told them I wouldn't erase that. I'll go over here. Just erase it. There's so many. Okay. I'm gonna do a good example. So I was to give you something crazy like the limit as x approaches, let's say 2. Yeah, like this. Well, technically it does work. Even though there is definitely a shortcut way of finding this limit, and you guys will actually, you'll see this when you get to homework, you're like, oh, that's what you mean. Like, it's not going to give you the actual function itself, it's just going to tell you, hey, guess what? The limit of this is this, and this is this, put it all together. So all this property is really telling you is I can split this apart, and I can do it individually as well, and it will still work. And the reason why that's nice, well, in this one's actually really nice. This isn't a discontinuity. It's not a hole. It's not a vertical asymptote. It's nothing crazy. However, there are going to be times when maybe a product or maybe a quotient or maybe a sum or difference is going to be a complicated function. You're like, I'm just not quite sure what to do with that. And so using this type of property, you can take a limit of a single and split it up to the limit of individual. That might help you. Does that kind of make sense? All right, with those fundamental theorems, actually, we are able to get to our algebraic strategies. thing is, this should be review for anyone who took pre-cal last year at Heritage.
What's pre-cal again?
This should be review, however, we're going to quickly go over them and remind ourselves. Now, I'm not going to do tons and tons of examples of each and every type because you have seen this before. You have seen this before. If you don't remember it, where could you go to get even more examples? Pre-cal notes, possibly. Pre-cal notes from last year. Mr. Crawford? He might not have taught this in Algebra 2. But pre-cal notes, or you could go to the book and then there are some examples. Some of you guys are like, this book is lame. It's just not as high schoolish. It's more college-ish. But there are going to be some examples to help you in there as well. And we talked about this before. Calculus is a really hard, like, college class, right?
Yeah.
When there's something that many people struggle with and really want help on, usually there's a demand, so then there's a supply. And where is the supply for help? Easy help to get to college kids and to get to people struggling with calculus? Online. Khan Academy, Patrick JMT, Math is Power for You, so many others. Wolfram Alpha, bad idea. That doesn't really teach very often. Come back. So, direct substitution. If you are able to, there are two ifs. If, first of all, by plugging in A, by just finding what is the y value at A, by plugging in A if it exists, and if A isn't a separator of a piecewise function, I'm going to write actually one more if, or actually I won't even write it as an if. I'll just say watch out for. There's like a but. But watch out for absolute values of functions. Absolute values of functions, they just kind of throw off our limits. We'll have to be careful with them when we get to them. But as long as it exists, and as long as there aren't any discontinuities, holes, vertical asymptotes, jumps, anything like that, we can just plug it in because as long as it does not exist, if I'm trying to approach 2 from the left and from the right, if it's a continuous function, then wherever I'm going when I approach 2, well, hold on. It says just plug in, see if it works. If I just plug in, I get 2 times 2 minus 1 times 2 plus 1, which my mental mathers end up equaling 6. Don't deflect. Either try it or keep quiet. 6. So, as I'm coming towards it, 1, 2, 3, 4, 5, 6. Long story short, if it's there and if there's nothing funky going on around it, it's a positive. You keep on finding, I'm just approximating. There's no reason to pick up my pencil. There's no jump. There's no hole. There's no vertical asymptote. Then, as I approach from the right and the left, if I did use a table, if I did use a graph, it would just be what's already there. And what's already there is a height of 6. So I can just plug in. I'm done. Nice, right? Mm-hmm. But hold on. This doesn't just say if f of a exists. It also says if a isn't a separator of a piecewise function. So maybe I can do this whole just plug it in with piecewise functions too? What if I was to give you the following example? What if I was to give you f of x is equal to and what if I was to give you the other piece of the function to be okay. What is the separator of this piecewise function? 0 is the separator. What do I mean by separator? I mean the boundary line. So x equals 0 is the separator. X equals 0 is the place at which all of this might go bad. In terms of, if you're trying to put together a puzzle, you're trying to look at the boundaries. And either the boundaries of the pieces will go together and fit, or the boundaries will be the place where it doesn't fit. That's kind of what's going on here with the separator. But if I was to give you this problem, bless you.
Bless you. Thank you.
If I was to give you this problem, do I even need to worry about my separator and how it might be a problem or not? No, I'm approaching something that's not my separator, so I don't really care about whether or not the puzzle piece is going together at the boundaries. What I'm caring about is what's going on at 3. Well, where would I look to see what's going on at 3? Right? Domain restriction, 3 is greater than 0, so therefore, oh, can I just plug in and solve?
Mm-hmm.
Yeah, of course I can. So if I go ahead and just plug in, what is f of 3?
5.
Yeah. Five. So as I come from below 3, as I come from above 3, all of it is taking place in this one piece, which is just a line. He doesn't have any jumps or holes or vertical asymptotes that's going to mess up anything. So therefore, sweet, I can just plug it in and then I'm done. Where I would have had to have been careful is if I was approaching a separator 0, and we'll see that in a little bit. So these ones work out super nice. I either plug in, he works, no problemo, or he looks really ugly, but I still just plug in, and he works, no problemo. So what happens if I do have a problemo? What happens, first of all, if I plug in and my denominator is 0? Well, if I plug in and my denominator is 0, does that mean there's no limit? Can't there be a limit that exists even if there's a hole? So I can't just stop. I try to plug in. I still do step 1. I try to do direct substitution. I try to plug in. Uh-oh, I get a denominator of 0. If I look a little closer. If it's a hole, I can factor out, and we call that a removable discontinuity. Quick review from pre-cal and algebra 2, right? Removable discontinuity means I can remove it. So therefore, if it's a hole, I can factor. I'm going to factor. I'm going to simplify out common factors. It's the way you've learned since forever. How do you know where a hole is? Well, the x tells you where a hole is because it's undefined. It's a discontinuity. But also you can factor out. You can remove that discontinuity. So in the following problem down below, what happens when I plug in?
Get 0.
I get 0
Over 0.
over 0. Oh. It's like I have the same zeros on the top and the bottom. That's interesting. The same zeros on the top and the bottom. That must mean I have the same factors, right, guys? If I have the same factors, I kind of need to factor the top so I can break them down a bit. And I end up with 2x minus 1, x plus 1. Did I have common zeros? But now what can I do that I've found my common zeros, my common factors? When I simplify, guys, this is a silly thing, and yet it confuses so many. What's left when I cross out 2 factors? It's a 1, not a 0, right? It's a 1. There's still a 1 on the denominator, technically. But all I've done is removed my hole and said, hey, what would be there? So long story short, at x equals -1, I can go ahead and just plug it in, substitute again. Once I've simplified out my common factors, I end up with 2 times -1 minus 1, which ends up being what? So let's recap real quick what's going on with the graph just to make sure that we understand. I have my function going through here. I have him coming up here, and I have him coming down, except he has a hole. However, guys, just because he has a hole at -1, x equals -1, does that mean he doesn't have a limit? What's he still getting closer and closer and closer and closer and closer to? The height of -3. So what's the algebra let me do? It lets me say, cool, there's a hole. I'll get rid of them. Sweet, plug it in. Got it, I'm done. I'm filling the hole, or I'm removing the hole and making it continuous behind. So if I have a hole, I can factor it out, no problemo. However, what if I have a vertical asymptote instead? What's different, guys, in both of these functions that wasn't true in this one? Don't be crying over factoring. Now we're really in trouble, folks. What was going on here that I can't do here?
Can't factor out.
Which is why vertical asymptotes are known as what kind of discontinuities? Non-removable. So I can't factor it out, right? Non-removable. I can't factor them out. That's how I know that they are vertical asymptotes. However, guys, didn't we see vertical asymptotes when we were talking about graphs? And even maybe tables? If we're coming towards a vertical asymptote, if we're coming towards a vertical asymptote, there's two directions I can head. What's one of them? As I'm coming towards that vertical asymptote wall, I can either skim it to positive infinity or I can skim it to negative infinity. So I know that the answer is either going to be a positive infinity or a negative infinity, or how could it not exist? Yeah, what if they were going different ways? As they came together, they didn't agree. Well, that's not going to work. So therefore, I'm going to have to take my one-sided limits and consider them separately. But I know as soon as I determine it's a vertical asymptote, the answer for the one-sided ones is going to be uninfinity. I just have to test the sign. And I just have to compare them and say, do they agree or do they disagree? Does it exist as a positive or a negative infinity agree, or does it not exist because they disagree? So at the end of the day, my hint is check the signs. And you'll see what I mean by that in these two examples. All I need is to know it's a vertical asymptote and then figure out what's the sign. Is it going to positive infinity or negative infinity? And this trick I'm going to show you will pretty much tell you every time, except or unless there is a weird funky function that even as you get infinitesimally close looks to be going up and then all of a sudden goes down. But you're not going to see any of those in this class. So no stress. So here's my trick. Take the one-sided limits. Well, hold on. He only is a one-sided limit, right? Where am I coming from? All right. I'm coming from the left. All right. Magical ones. Without a calculator, visualize that graph and tell me where I'm going. Okay, stop that because it's not worth it. Let's do a shortcut. Sound good? Why am I saying don't visualize that graph? Yeah, is that a basic graph? Could I maybe multiply top and bottom by 1 over x and do mental contortions and hope that I figure out what it looks like? Let's not. Let's not be a mental contortionist. Instead, let's do a really simple shortcut. Number line. Here's 3. What's something that's getting pretty stinking close to 3 from the left?
25.
Why do we usually hate decimals, especially when we're trying to evaluate functions? Didn't I just say you couldn't use your
Calculator.
But did I say you had to check the number answer or the sign?
Sign.
Okay, so let's see if we can check the sign. First of all, if we plugged in 3, let's hold on, go back to the very beginning. You always try to plug in. What happens when I do plug in?
0 over 0.
Not 0 over 0.
No. I don't know. 3 over 3. 3 over 0.
Is there a common 0? So is there going to be a common factor? So therefore, ooh, it's a vertical aspect. Okay, come back. So I can't just keep going with factoring because it is impossible. I don't have a common 0. But what I can do is I can say, hey, if I just think of something kind of, 2.99, sure. Then I can imagine what's going to happen when I plug in 2.99 over 2.99 minus 3, and I can just say, wait a minute, I know the answer is one of these if it's a one-sided limit, so which one? Well, guys, if I go 2.9, 2.99, 2.99, 2.99, what's my sign? On top. Positive. What's my sign on bottom? 2.9, 2.99, 2.99. They're all going to be. They're all going to be. So what's my limit?
Negative infinity.
It's negative infinity. Now, is this actually plugging in and getting the negative infinity answer? No, but it's me using my mathematical knowledge to say this is a discontinuity that's non-removable. This is my discontinuity that's non-removable, and so therefore I can check the sign and answer. Now, guys, we're just a little bit behind period 1, so that's okay. We'll catch up because they need to take another day on 2 as well. However, your homework tonight is what?
Homework number.
Start it and get as stinking far as you can on it, and I will see you guys tomorrow. Bye. Oh, we got a hand up. Hold on, take one on the way out. Not due tomorrow, however, they are AP questions on limits, and if you can start on them, it will probably be due next Tuesday. Bye, guys.